With Kotlin 1.5, the standard library receives another upgrade. Whether you're working with numbers and strings, collections, paths, time durations, or even tests, it's got something for you. Stick around to learn about the highlights for this release. First up, new ways to work with numbers come in the form of stable support for unsigned integer types. Concretely, this means that we have 4 new types to work with: ubyte, ushort, uint, and ulong. Don't mistake that last one for oolong, the Chinese tea. Unsigned numbers can be created via the included conversion functions or by suffixing a number with a u for unsigned. Other number-related packages like random also receive extensions to directly create unsigned values. These types for unsigned numbers are useful wherever you want to constrain a type to only contain non-negative values. They can also be more intuitive when you're working on bit and byte level, manipulating pixels in a bitmap, the bytes in a file, or other binary data. Unsigned integers also shift the value range, allowing you to store larger non-negative numbers in the same amount of memory. Where a regular int can store numbers from roughly -2 billion to +2 billion, a uint, for example, can represent numbers between 0 and a bit over 4 billion. This is also the reason why I can store OXFF, so hexadecimal 255, in an unsigned byte, something that I can't do in a regular byte because its value range only goes up to 127. Just like for other number types, you get arithmetic operations out of the box to manipulate and convert unsigns. It's also possible to create ranges and progressions from unsigned integer types. What makes these unsigned numbers particularly versatile is their implementation on top of value classes. Simply said, you don't have to incur performance penalties when using these number types instead of the signed primitives that the JVM has to offer. The compiler can optimize the unsigned abstraction away, meaning you can make your code more expressive without adding needless memory allocations. Neat! Unsigned integer types are stable with Kotlin 1.5, meaning you can use them without opt-in or worry in your production projects. Arrays of unsigned integer primitives and the corresponding specialized collection operations remain in beta, but you can opt in to using those. By the way, I'd have to say my favorite function for unsigned numbers is the toString method, which takes a radix, allowing me to quickly print the hexadecimal or binary representation of my data if I want to. And speaking of strings, let's talk about the new string capitalization functions Kotlin 1.5 introduces. The previous functions toUpperCase, toLowerCase, and toTitleCase make way for the new uppercase, lowercase, and titlecase functions alongside their counterpart for individual characters. At first, you might not actually notice a difference in behavior. But these new versions are locale agnostic. This means that no matter the language settings on the target system, you will get consistent capitalization results. Beforehand, on systems with some international language settings, capitalizing a word would use its local representation, meaning Kotlin, in all caps, on a system with the Turkish locale, for example, would get a little dot over the I, which might not be what you're expecting. As you can see, it's still possible to do this locale-based case change, but now we make it explicit and the more common behavior becomes the default. Hopefully this will save you some headaches down the road. 1.5 also provides some additional convenience functions for creating Boolean values from strings. You might already know the toBoolean function, which you can use on nullable and regular strings. It returns true when it encounters the string true, regardless of how the word is capitalized, and false on all other strings, including if the string is null. Now, you also have the toBoolean strict function, which maps true and false to their Boolean values and throws an exception in any other case. And there's also the sibling function toBoolean strict or null, which returns null for all inputs that aren't exactly the true or false strings. For individual characters, we're now also introducing functions that make their conversion into numbers more expressive. The main point is this: when you're converting a character into a number, you can mean one of two things. You either mean the char code for the character in question, or you mean the actual digit the character represents, parsing the number. With Kotlin 1.5, you can express both of these quite concisely. With the code property, you can get the numeric char code of a character. For capital A, that would be 65, the digit 4 would be 52. The other way around, you can use the char constructor with a code as its argument to create a character based on that char code, turning code 66 into a capital B. If instead you're interested in the actual digits represented by the character, there are the digit to int function and its nullable version, digit to int or null. these create an integer from a character representing an individual digit. Feeding it a 4 gives you the number 4. It also accepts a radix, so you can easily parse hexadecimal numbers, for example, turning the character A into a 10. Also, attention all Kotlin multi-platform enthusiasts. 1.5 makes a number of functions to check character properties available in common code. They help you when you want to check if a character is a digit, a letter, or either one of them, whether a letter is upper, lower, or title case, and whether its Unicode representation is defined or an ISO control sequence. Next up, let's talk about new functionality regarding integer division. In Kotlin, the division operator on integers represents the truncated division. That means it drops the fractional part of the result. For positive integers, this very much matches the intuition because it behaves like a round down. But especially when you're working with negative numbers, there's a bit more nuance to it. Starting with Kotlin 1.5, you can now use the floor_div function to perform flawed division on integers. The difference is that flawed division always rounds the result down towards the lesser integer. As you may imagine, that makes a difference for negative numbers. In tandem, we're also adding the corresponding remainder function called mod. The mod function returns the modulus, that is, the remainder of the flawed division. And that is different from the percent operator called rem in Kotlin. The main difference between them is the sign, whether the result is positive or negative. The new function mod always produces a non-negative value, even when it's invoked on a negative integer. This is helpful when you're working on circular data structures, for example, and want to ensure that you always generate non-negative indexes for accessing an underlying array. Next, let's talk about the newly added extensions for using Java NIO from Kotlin. NIO stands for non-blocking I/O, which, as you may know, is a set of abstractions provided on the JVM for intensive I/O operations. With Kotlin 1.5, we now have a number of idiomatic extensions for it. For example, we can directly create a path instance by passing a string without using the .off function. And instead of concatenating strings, we can now construct subpaths using the division operator when we have a given base path, or we can easily list entries in a directory, even filtered with glob patterns. Unfortunately, it is a bit beyond the scope of this video to discuss all the extension functions for working with NIO paths that have been stabilized, because there are a few dozen of them. But as usual, I'd suggest exploring them, either via your IDE's autocomplete or in the API documentation found on kotlinlang.org. Next up, Kotlin collections. You might be familiar with the situation where you have a list of objects, all with a nullable property, and you want to get the first non-null value of that property in the collection. How you would usually approach this would be to first use map.not_null to get a collection of all the potential values, and then call first or null to get the final value. But this either creates another intermediate list of all the age elements in this case, or you have to explicitly convert this chain into a sequence. With Kotlin 1.5, we can do better. With the first not null off and the first not null off or null functions, we can express the same concept with a single call. And while the name is a bit of a mouthful, it really describes the functionality. The function returns the first non-null value of the past selector, or null if no element matches. 1.5 also continues to evolve the duration API, which is the standard library's way of providing precise measurements for time intervals. And while it stays experimental for now, it keeps evolving, and we'd love for you to try it and give your feedback. If you haven't checked it out yet, the Kotlin duration and time measurement APIs help you work with time in a type-safe fashion. It provides abstractions for different units like hours, minutes, and seconds, as well as mechanisms to mark points in time and measure durations via time sources. Now it also comes with fresh new constructors for creating durations of different types. The biggest change for them in 1.5 is an under-the-hood change. The value class defining a duration now internally uses a long instead of a double. This means it can now represent durations of more than 100 years with nanosecond precision or 100 million years with millisecond precision. The trade-off is that sub-nanosecond durations are no longer available. And this change is also binary incompatible, so if you're maintaining a library that uses the experimental duration API, please make sure to recompile it using 1.5's new long-based version. When working with duration objects, we are also providing new properties for receiving a duration as a long value in different units. There's duration in whole minutes, in whole seconds, and so on. Last but certainly not least, the Kotlin test library also receives some love with Kotlin 1.5. Besides configuration improvements for multi-platform projects and automatic JVM test framework selections, the star of the show are the new assertion functions, which help you write concise test invariants for a number of common cases. To check the type of a value, you can now use the assertIs and assertIsNot functions with a generic parameter of your choosing. For collections, sequences, and other iterables, the assertContentEquals function compares whether expected and actual arguments contain the same elements in the same order. And when you're doing assertions on doubles or floats, you can now find overloads for the assertEquals and NotEquals functions with a precision parameter. Why is that useful? Well, as you may know, floating point numbers are by definition ever so slightly imprecise, and with the precision parameter, we can control for slight deviations and still concisely express our invariants. That's it for this overview of standard and test library changes in Kotlin 1.5. For more information around this release and other fun Kotlin content, check out our other videos right here on the Kotlin channel, and don't forget to like and subscribe. We hope you enjoy these new additions to the Kotlin standard library. Now it's time to go ahead and explore some more Kotlin. See you in another video.